Quideo 4 Advanced. A researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this conducted in a greenhouse. For a large number of Roma tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of 12 containers. One of the 2 seeds is randomly selected and treated with the additives. The other seed serves as a control. Both seeds are then planted in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. These data were used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not unreasonable. For this problem, we're going to use phantoms. So, P is your parameter again. We're looking to see if there's a growth between tomatoes with additives and without. Your mu of A, we're going to label as the ones with additive, and the mu of W we're going to use without. So for the H, our HO is the mean of the additives minus the mean of those without equals 0, and the HA is that they do not equal 0. For A, we assume normality due to the SRS. N, we label it as a one-sample t-test because, again, we only have a sample. For T for the test, we're going to use this equation. This is T. T equals x bar minus the mean over standard deviation divided by the square root of n. So we plug in our things. X bar is negative 2.05. 0, because that's the difference, divided by the standard deviation all over n, square root of n. This gives us negative 6.002. Using this, we do the absolute value because we're going to go to table C and look at our t-values. We have a degrees of freedom of 11. When we look for 6.002, we realize that all the way on the end, it's not even here, which means that our probability is less than 0.0005. So for M and S, we reject the HO because the p-value is less than 0.005, so there's no significant growth between the two.